Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in today's session, we are going to discuss NEET 2023 physics paper for Manipur state, and we are 50 questions here. So let's start the session. The first question is from the chapter Magnetism and Matter, and the question is the variation of susceptibility with absolute temperature for a paramagnetic material is represented as. Okay, so we have to choose the correct graph representing the relation of susceptibility with absolute temperature. Okay, so we know that for paramagnetic substances, for paramagnetic substances or material, the susceptibility is inversely proportional to the temperature. Okay, but here we have the relation between susceptibility and 1 by T, not T. Okay, so we can say that susceptibility is inversely proportional to temperature, or it is directly proportional to the reciprocal of temperature. Okay, so since we have to find the relation with reciprocal of temperature, so it will be a straight line, okay, showing the direct relation. So according to that, option A will be the correct answer. Question number 2 is from the chapter Work, Energy and Power, and the question is a bullet of mass small m hits a block of mass capital M elastically. The transfer of energy is maximum when? Okay, so we know that in elastic collision, the maximum energy is transferred when the masses are equal. Okay, m1 is equal to m2. So here m1 is equal to small m and m2 is equal to capital M. So for maximum energy transfer, small m should be equal to capital M. That means option A will be the correct answer. Question number 3 is from the chapter Atoms, and the question is the ground state energy of hydrogen atom is minus 13.6 electron volt. The energy needed to ionize hydrogen atom from its second excited state will be. Okay, so here we are talking about the hydrogen atom. Now we know that the energy in the nth orbit is given by the formula minus 13.6 Z square upon N square electron volt, right? Now we are talking about the hydrogen atom, so we know that for hydrogen atom the atomic number will be 1, that means the value of Z will be 1. Okay, so this energy will be inversely proportional to the N square, right? Now we also know that the value of N is 1 for ground state. Okay, then the value of N is 2 for the first excited state. Similarly, the value of N will be 3 for second excited state. Now here the question is about the second excited state, so the value of N will be 3. Okay, now here the ground state, suppose the ground state energy is equal to E1 and we have to find the energy in the second excited state, that means E2. Okay, so E2 upon E1 will be equal to N1 upon N2 square. Okay, because E is inversely proportional to N, right? Now E2 we have to find. E1 is given, that is equal to 13.6 electron volt. That is equal to N1, that means 1 upon N2. This is N2, okay? So N2 is equal to 3 here for second excited state. So 3 square, okay? And 1 by 3 square will be equal to 1 by 9. So from here we can easily find out the value of E2. That will be equal to 13.6 upon 9, okay? Divided by 9. So on dividing this, we'll get the value 1.51 electron volt. Just remember that ionization energy is never negative, it will always be positive. So option C will be the correct answer. Question number 4 is from the chapter Gravitation, and the question is the escape velocity of a body on the Earth's surface is 11.2 km per second. If the same body is projected upward with velocity 22.4 km per second, the velocity of this body at infinite distance from the center of the Earth will be. Okay. So escape velocity is given. We know the value of escape velocity. It is 11.2 km per second. Now it is given in the question if the body is projected upward with velocity 22.4 km per second. So this is the given velocity. 22.4 km per second, that is 2 times the escape velocity. Okay, so this is 2 times the escape velocity. Now we have to find the velocity at infinite distance from the center of the Earth. That means we have to find the interstellar velocity. Okay, so interstellar velocity is given by the formula under root square of given velocity minus square of escape velocity. Okay, now we know that the given velocity is 2 times the escape velocity. So 2 times the escape velocity, square of this minus square of escape velocity. So here we get 4 times escape velocity square minus escape velocity square, that is equal to root 3 times escape velocity. Okay, and we know that escape velocity is 11.2 km per second. So it will be equal to 11.2 root 3 km per second. Therefore, the correct answer will be option number D. Question number 5 is from the chapter Ray Optics and Optical Instruments, and the question is a lens is made up of 3 different transparent media as shown in figure. A point object O is placed on its axis beyond 2f. How many real images will be obtained on the other side? So we know that the number of real images will depend on the number of refractive index. Okay, so since this lens is made up of 3 different transparent media, therefore 3 different refractive indices are there. Therefore 3 types of images can be formed. That means the number of images that can be formed will be 3. Okay, so option D will be the correct answer. Question number 6 is from the chapter Units and Dimension, and the question is the diameter of a spherical bob when measured with vernier calipers yielded the following values: 3.33 centimeter, 3.32 centimeter, 3.34 centimeter, 3.33 centimeter, and 3.32 centimeter. The mean diameter to appropriate significant figures is. Okay, so we have to find the mean diameter, right? That will be the average diameter. So that is equal to D1 plus D2 plus D3 plus D4 plus D5 divided by the number of diameters, that is 5. Okay. So D1 is 3.33 centimeter, D2 is 3.32 centimeter, D3 is 3.34 centimeter, D4 is 3.33 centimeter, and D5 is 3.32 centimeter. So this sum will be divided by 5. Now on solving this, we'll get the value 3.328. Now here we have to find the mean diameter to appropriate significant figures. Now you can see that all the diameters mentioned here have 2 digits after the decimal, right? So the answer will also have only 2 digits after the decimal. So if we round it off, we'll get 3.33 because the third digit after decimal is greater than 2, right? So 3.33 centimeter will be the answer. So option C will be the correct answer. Question number 7 is from the chapter Current Electricity, and the question is on the basis of electrical conductivity, which one of the following material has the smallest resistivity? Options are germanium, silver, glass and silicon. So it's very simple. We know that the best of the conductors will have smallest resistivity, okay, and best conductivity. So here if you see, glass is an insulator. So it will have the maximum resistivity. Okay, then germanium and silicon, these two are semiconductors, so these will have moderate resistivity because they are semiconductors. But silver is a very good conductor. Okay, so it is the best conductor among them. Therefore, it will have the maximum conductivity, or you can say minimum resistivity. Okay, smallest resistivity. Therefore, option B will be the correct answer. Question number 8 is again from the chapter Units and Dimension, and the question is the mechanical quantity which has dimensions of reciprocal of mass is. So mass should be on the denominator side, right? Now let's see the options. The first option is angular momentum, whose formula is mvr. So here mass is not on the denominator side, so the dimension will not have the reciprocal of mass here. Okay. Then the second one is coefficient of thermal conductivity, that is equal to QL divided by A delta T. Okay. And heat has mass in it. Okay. It is mc delta T. So here also mass is on the numerator side, not on the denominator side. So it will also not have the reciprocal of mass. Then the third one is torque. Torque is given by the formula force into distance. Now force is equal to mass into acceleration. So mass is not on the denominator side here. So the dimension of torque will also not have reciprocal of mass. Then the last one is gravitational constant. Now what is the formula for gravitational force? It is equal to G m1 m2 upon r square. So the gravitational constant G will be equal to Fr square divided by m1 m2. Now only in this option we can see that mass is on the denominator side. So the dimension of gravitational constant will have the reciprocal of mass. So option D will be the correct answer. Question number 9 is from the chapter Motion in a Straight Line, and the question is the position of a particle is given by vector r equals to 4t I cap plus 2t square j cap plus 5k cap, where t is in seconds and r is in meter. Find the magnitude and direction of velocity at t equals to 1 second with respect to x-axis. Okay. So here the position vector is given as 4t I cap plus 2t square j cap plus 5k cap. Now we have to find the velocity. So velocity vector will be equal to differentiation of the position vector with respect to time. So on differentiating this, we'll get 4 I cap plus 2 into 2 4t, 4t j cap plus this side we have a constant, so 0 k cap. Okay. So 4 I cap plus 4t j cap is the velocity vector. Now we have to find the magnitude of velocity at t equals to 1 seconds. At t equals to 1 seconds, we'll put the value of t as 1. So here we get 4 I cap plus 4 into 1 j cap, isn't it? That is equal to 4 I cap plus 4 j cap. So this is the velocity vector. The magnitude of velocity will be equal to under root a square plus b square, that means 4 square plus 4 square, 4 square plus 4 square, that means under root 32. So that will be equal to 4 root 2. This is the magnitude of the velocity, okay, and the unit will be meter per second. Now we also have to find the direction of velocity. So direction of velocity, for that we know that tan theta will be equal to Vj upon Vi. Okay. So Vj is 4, that means the vertical component, divided by the horizontal component 4. 4 by 4 is equal to 1. So tan theta is equal to 1. That means the value of theta will be 45 degree, because the value of tan 45 degree is 1. Okay. So the magnitude will be 4 root 2 meter per second and the direction will be 45 degree. So according to that, option A will be the correct answer. Question number 10 is from the chapter Thermodynamics, and the question is for the given cycle, the work done during isobaric processes. Okay. Now if we look at this graph, this is PV graph. Okay. That means pressure versus volume graph. Now the part AB, this part has a constant pressure, right? 3 into 10 to the power 2 Newton per meter square. So this is the isobaric part. the part having constant pressure. If we talk about the part AC, this one from here to here, from A to C we have a constant volume, right? So this is not isobaric part, this is isochoric part having constant volume. So if we had to calculate the work done of the complete cycle, the complete process, then we would calculate the area of this triangle. But we have to find the work done of only the isobaric process, not the isochoric process. Okay. So for that we will consider that the graph is like this, only from A to B, because only this part has constant pressure. Only this part is the isobaric part. Okay. So for that we will have to calculate the area of this part. Okay. The area under this line, that is this rectangular. Okay. So what will be the length of this rectangle? The area will be length into breadth, right? So the length of this rectangle will be this one. That means 3 into 10 to the power 2. And breadth will be this one. Okay, here we have 3, here we have 1. So breadth will be 3 minus 1. So it will be equal to 3 minus 1, that is 2, and 2 into 3 will be 6. So 6 into 10 to the power 2, that is 600. And the unit of work done will be joule. So 600 joule will be the answer. So option D will be the correct answer. Question number 11 is from the chapter Electrostatic Potential and Capacitance, and the question is the equivalent capacitance of the arrangement shown in figure is. So if you look at this figure, you will see that these three capacitances are in series combination, okay, like this. Here we have three capacitances in series combination, each of 15 microfarad. Now we know that for series combination, the equivalent capacitance is same as the equivalent resistance in parallel combination. Okay, that means 1 by C equivalent will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. That means 1 by 15 plus 1 by 15 plus 1 by 15. So 1 by C equivalent will be equal to 3 by 15. So what will be the C equivalent? It will be equal to 15 divided by 3. That means 5. Okay. This is only for the part of series combination. Okay. Then we have another capacitance of 15 microfarad that is in parallel combination with these. Okay. So for parallel, C equivalent is equal to C1 plus C2. So C1 is 5 and then C2 is 15 microfarad. So here we get 20 microfarad. Okay. So 20 microfarad, option D will be the correct answer. Question number 12 is from the chapter Alternating Current, and the question is an AC source is connected in the given circuit. The value of phi will be, V is given as 220 sine omega pi t plus 5 volt. Okay. So we have to find the value of phi, that is phase difference. We have to find the value of phase difference. Okay. Now in this formula of voltage, you can see that the value of omega is equal to 100 pi. Okay, because this is omega t plus phi. So omega is equal to 100 pi here. Then from this circuit, you can see this inductance is given as 1 by pi Henry. So the value of L is 1 by pi. Now we know that tan phi is given by the formula XL upon R, and XL is equal to omega L divided by R here. Omega is equal to 100 pi, we have seen 100 pi, and L is given as 1 by pi in the circuit, okay, divided by the resistance. So resistance R is given as 100 ohm here, okay, in the circuit only you can see 100. Now we just have to solve it. So pi will be cancelled. This is 100 divided by 100. That means 1. So tan phi is equal to 1. So what will be the value of phi? It will be 45 degree, because tan 45 degree is equal to 1. So option D will be the correct answer. Question number 13 is from the chapter Semiconductor Electronics, and the question is the given circuit is equivalent to. So we can see that the inputs A and B are going through the NOT gate. Okay. So first A will get converted into A bar, and B will get converted into B bar, okay, because both are passing through a NOT gate. Then these two are passing through the NOR gate, okay. So what will be the output? We know that in OR gate, these two will be added, A bar plus B bar. But since we have a NOR gate, so due to the NOT, it will have an additional bar here, okay. So A bar plus B bar and a whole bar over them. Then that will be equivalent to A double bar dot B double bar, okay. It can be written like this. Now again, it will be equivalent to A dot B because double bar will get cancelled. So we'll cancel each other. So A dot B, which is the output in case of AND gate. So we can say that this given circuit is equivalent to an AND gate, which is given in option D. So option D will be the correct answer. Question number 14 is from the chapter Work, Energy and Power, and the question is, a particle moves with a velocity 5 I cap minus 3 j cap plus 6 k cap meter per second horizontally under the action of a constant force 10 I cap plus 10 j cap plus 20 k cap Newton. The instantaneous power supplied to the particle is. So we know that instantaneous power is given as vector F dot vector V. That means the dot product of force and velocity vector, right? So what will be the dot product? 5 into 10, then minus 3 into 10 j cap plus 6 into 20 k cap. Okay. So 5 into 10 is 50, minus 3 into 10 is minus 30, and 6 into 20 will be 120. So on solving this, we'll get 140, and the unit of power will be watt. So 140 watt, that means option D will be the correct answer. Question number 15 is from the chapter Current Electricity, and the question is, a certain wire A has resistance 81 ohm. The resistance of another wire B of same material and equal length but of diameter thrice the diameter of A will be. Okay, so the length of another wire is same as that of the initial wire, but its diameter is 3 times the diameter of the first wire. Okay, so we know that area is proportional to the square of radius. Okay, if diameter is thrice, that means the radius is also thrice. So the area will become 9 times. Okay, when the radius will become 3 times the radius of the first wire, then area of the new wire, the second wire, will be 9 times the area of the first wire. Okay. Now we know that resistance is inversely proportional to the area. Therefore, the new resistance will be 1 by 9 times the initial resistance. Okay. So that will be equal to 1 by 9 into 81 ohm. That is equal to 9 ohm. Right. Option B will be the correct answer. Question number 16 says that epsilon naught and mu naught are the electric permittivity and magnetic permeability of free space respectively. If the corresponding quantities of the medium are 2 epsilon naught and 1.5 mu naught respectively, the refractive index of the medium will nearly be. Okay. So we know that the electric permittivity of a medium, that is epsilon m, is equal to epsilon r into epsilon naught, where epsilon r is the relative permittivity. It is the relative permittivity, and epsilon naught is the electric permittivity of free space. Okay. Now this is given in the question as 2 epsilon naught. Okay. That means epsilon r, epsilon naught is equal to 2 epsilon naught. So from here we can say that the value of epsilon r is 2. Okay. Similarly, if we talk about the magnetic permeability, so the magnetic permeability of a medium mu m is equal to mu r into mu naught. Okay, and in this question the value is given as 1.5 mu naught. That means from here we can say that the value of mu r is equal to 1.5. Okay, relative permeability is equal to 1.5 according to this question. Now we have to find the refractive index of the medium. So refractive index of the medium is equal to under root mu r into epsilon r. Okay, this is the formula for relative refractive index. So that will be equal to mu r, that means 1.5, so it can be written as 3 by 2, and epsilon r is 2. So this is equal to under root 3, right? So option B will be the correct answer. Question number 17 is from the chapter Mechanical Properties of Solids, and the question is the amount of elastic potential energy per unit volume in SI unit of a steel wire of length 100 centimeter to stretch it by 1 millimeter is. Okay, we have to find the amount of elastic potential energy of this wire. Okay, Young's modulus of the wire is given as 2 into 10 to the power 11 Newton per meter square. Now length of the wire is 100 centimeter. That means 100 into 10 to the power minus 2 meter, because we have to use SI unit. Okay, it can be written as 10 to the power 2 into 10 to the power minus 2 meter. Now it is stretched by 1 millimeter. So the delta L, that means change in length, is 1 millimeter, or we can write it as 10 to the power minus 3 meter. This is the value of delta L. What will be the strain? We know that strain is equal to delta L divided by L. So this will be equal to 10 to the power minus 3 divided by 10 to the power 2 into 10 to the power minus 2. That means the value of strain is 10 to the power minus 3. Okay, now what we have to find out? We have to find out the amount of elastic potential energy. So the formula for elastic potential energy using strain will be half into gamma, that is modulus, Young's modulus of the wire, into square of strain. Okay, we have various formula, but using strain we have this formula. So half into the value of gamma is given as 2 into 10 to the power 11 Newton per meter square. Strain we have calculated 10 to the power minus 3. So the square of strain, that means 10 to the power minus 3 square. So here 2 will get cancelled. 10 to the power 11 into, here we'll get 10 to the power minus 3 square, that means 10 to the power minus 6. So on solving this, we'll get 10 to the power 11 minus 6, that is 5. So this is the answer. That means option D will be the correct answer. Question number 18 is from the chapter Sound, and the question is the fourth overtone of a closed organ pipe is same as that of third overtone of an open pipe. The ratio of length of the closed pipe to the length of open pipe is. Okay, so we know that for a closed pipe, for a closed organ pipe, the frequency is given by the formula 2n plus 1 into V upon 4L. Okay, here L is the length of closed pipe, so we'll write LC. Okay, what is N here? N is the overtone, number of overtone. So in the first case, it is given we have fourth overtone of the closed organ pipe, so we'll put the value of N as 4. So here we'll get 2 into 4 plus 1 into V upon 4 LC, that is length of the closed pipe. So 2 into 4, 8 plus 9. So 9V upon 4 LC, this is the frequency. And for open pipe, we know that the formula for frequency is N plus 1 into V upon 2L. Okay, so here it is the third overtone of the open pipe. So the value of N will be 3 here. So 3 plus 1, 4V upon 2L. Okay, that is equal to 2V upon L. Here L is the length of open pipe, so we'll write LO here. Now these two frequencies are equal. It is given in the question. These two frequencies are same. And we have to find out the ratio of the length of the closed pipe to length of the open pipe. That means we have to find LC upon LO. So these two are equal. Let's equate them. 9V upon 4 LC is equal to 2V upon LO. We have to find out the ratio LC upon LO. So 9V upon 4 into 2V will be equal to LC upon LO. Okay, this LC we have brought here and this 2V we have brought this side. So this ratio will be equal to 9 upon 8. V will be cancelled. Okay, So 9 is to 8 is the ratio. That means option C is the correct answer. Question number 19 is from the chapter Magnetic Effect of Electric Current, and the question is, a long straight wire of length 2 meter and mass 250 grams is suspended horizontally in a uniform horizontal magnetic field of 0.7 Tesla. The amount of current flowing through the wire will be. The value of G is given as 9.8 meter per second square. Okay, so we have a wire of length 2 meter and mass 250 grams, that means 0.25 kg, or we can say 1 by 4 kg. So this wire is suspended horizontally in a uniform horizontal magnetic field of 0.7 Tesla. Okay. Now in the absence of any magnetic field, this wire would have fallen due to the weight mg. Okay. It would have fallen down due to the weight mg. But since a magnetic field exists here, so the force due to this magnetic field will balance this wire in this position and it will prevent the wire from falling down. Now this force will be given by the formula B into I into L. Okay, so these two forces are balancing each other. That means mg is equal to B into I into L. I is the electric current flowing through the wire that we have to calculate, the amount of current flowing through the wire. So I will be equal to mg upon B into L. M, that means mass, is given as 1 by 4 kg. Okay, the value of G is given as 9.8 meter per second square. Then here we have B, that means the magnetic field. So that is given as 0.7 Tesla and the length of the wire is 2 meter. So we have to solve this, and on solving this we'll get 1.75 and the unit of current will be ampere. So 1.75 ampere will be the answer. Option number D will be the correct answer. Question number 20 is from the chapter Electric Charges and Fields, and the question is, according to Gauss law of electrostatics, electric flux through a closed surface depends on option A, the area of the surface, option B, the quantity of charges enclosed by the surface, option C, the shape of the surface, and option D, the volume enclosed by the surface. So this is a very easy question. This is direct theoretical question. Okay, we know that according to the Gauss law of electrostatics, the electric flux through a closed surface is equal to Q inside or Q enclosed divided by epsilon naught. Okay, so this flux depends only on the charge enclosed by the surface. That means option B will be the correct answer. Question number 21 is from the chapter Motion in a Plane, and the question is, a ball is projected from point A with velocity 20 meter per second at an angle 60 degree to the horizontal direction. At the highest point B of the path as shown in the figure, the velocity of the ball will be. Okay, so this B is the highest point here. Now at highest point, what will be the vertical velocity? Vertical velocity will be 0 because it is not going any higher now. It is the highest point. And what will be the horizontal velocity? Horizontal velocity will be equal to u cos theta. U is given as 20 meter per second. Cos theta. Theta is 60 degree. Okay, cos 60 degree will be equal to half. So 20 into half, that means 10. This will be the velocity at highest point. Option D will be the correct answer. Now question number 22 says, which of the following statement is not true? Okay, so we have to find out the wrong statement. The first statement says that coefficient of viscosity is a scalar quantity. This is a correct statement, okay, because coefficient of viscosity does not have any direction. Then the second statement says surface tension is scalar quantity. This is also correct. Okay, surface tension is a scalar quantity. It also not has any direction. Third one is pressure is a vector quantity. This is wrong, okay, because pressure is a scalar quantity. Okay, it is not vector quantity. Then the last statement says relative density is a scalar quantity. This is correct. So the only incorrect statement is the third one. So option C will be the correct answer. Question number 23 is from the chapter Magnetic Effect of Electric Current, and the question is, a uniform electric field and a uniform magnetic field are acting along the same direction in certain region. If an electron is projected in the region such that its velocity is pointed along the direction of the fields, then the electron, option A, will turn towards right of the direction of motion, option B will turn towards left of the direction of motion, option C, speed will decrease, and option D, speed will increase. Okay. So we have a uniform electric field. This is the electric field, and a uniform magnetic field along the same direction. Okay. Then an electron is projected in a region, suppose this is the electron, this is projected in the region such that its velocity is pointed along the direction of the fields. Okay, its direction is also same as the direction of electric and magnetic fields. Then what will happen to the electron? Okay, now we know that when the magnetic field and electron, the velocity and the magnetic field have same direction, then there will be no magnetic force. Okay, so magnetic force will be zero because the direction of magnetic field and the velocity of the electron is same. And what will be the electric force? Electric force. So we know that for negative charge, electric force will be in the backward direction, okay, in the opposite direction. It will be in the opposite direction to the velocity of the electron, right? That means the speed will decrease because the force is opposite to the velocity of the electron. Therefore, its speed should decrease. Direction will not change. Direction will remain same, but only the speed will decrease due to the opposing force, opposing electric force. So option C will be the correct answer. Question number 24 is from the chapter Ray Optics and Optical Instruments, and the question is, a horizontal ray of light is incident on the right angled prism with prism angle 6 degree. If the refractive index of the material of the prism is 1.5, then the angle of emergence will be, okay. So the angle of the prism is given as 6 degree. We know that the angle of prism is equal to R1 plus R2. Okay. Now since this was a horizontal ray of light, so if this is your triangle, right angle prism, this is the horizontal ray. So with normal, this ray is making an angle of 0 degree. So angle of incidence is 0 degree. So R1 is also 0 degree. Okay. An angle of prism is 6 degree. R1 is 0 degree. So we can find out the value of R2. R2 will also be equal to 6 degree. Okay. Now we have to find out the angle of emergence, this angle. So we'll apply the Snell's law here. Snell's law. So using that law, we can say that sine R2 upon sine E will be equal to refractive index of air, that means 1, divided by the refractive index of the material of the prism, 1.5. Now for small angles, we can write sine theta as theta. So it will be R2 by E equals to 1 by 1.5. R2 is equal to 6, right? We have to find out the value of E. So E will be equal to R2 into 1.5, that means 6 into 1.5, that is equal to 9 degree. So this will be the angle of emergence. Option A will be the correct answer. Question number 25 is from the chapter Semiconductor Electronics, and the question is, a p-type extrinsic semiconductor is obtained when germanium is doped with. Options are antimony, phosphorus, arsenic, boron. Now we know that antimony, phosphorus and arsenic are pentavalent, whereas boron is trivalent. Now we know that for n-type semiconductor, there should be extra electrons, and extra electrons are donated by the pentavalent atoms, okay, pentavalent. But here we don't have to get an n-type semiconductor, we have to get a p-type semiconductor. So for that, holes should be present, not electrons. So for that, we have to dope germanium with a trivalent atom. That means option D, boron, will be the correct answer. Question number 26 is again from the chapter Ray Optics and Optical Instruments, and the question is, which set of colors will come out in air for a situation shown in figure. So we have this white color, this is the glass slab. This green color is moving along the surface, right? That means for green color, the critical angle is equal to the angle of incidence. Okay. We know that total internal reflection takes place in which case? Where the angle of incidence is greater than the critical angle. Okay. So when the angle of incidence is greater than the critical angle, in that case total internal reflection takes place and light moves back to the same medium. Okay. But if this angle of incidence is less than the critical angle, okay, that means if the critical angle is more or greater than the incident ray, in that case no total internal reflection will take place. That means the light ray will not move backward. Instead the light or color will come out in the air. Okay, so this is asked in the question that which set of colors will come out in the air. So for that we should know that which color has greater critical angle. Okay, we have 7 colors: violet, indigo, blue, green, yellow, orange and red. As we move down, the wavelength increases. Okay, also we know that the critical angle is directly proportional to the wavelength. So more the wavelength, more will be the critical angle. More is the critical angle. So which colors will come out of this glass? The colors which have more critical angle than green color. Okay. So if we talk about the colors which are present before green, these have less critical angle because their wavelengths are lesser than that of green. Whereas the colors which are after green, that means yellow, orange and red, have more wavelength than green color. So these colors will have more critical angle. Therefore, these 3 colors will come out of the glass slab. So yellow, orange and red, option A will be the correct answer. Question number 27 is from the chapter Alternating Current, and the question is, if Z1 and Z2 are the impedances of the given circuits A and B as shown in figures, then choose the correct option. Okay, so we have this first circuit, this is second circuit. Okay, this is circuit number 1, this is circuit number 2. Now if we talk about the first circuit, we can see that this is a DC. Okay, direct current is there. It is the case of DC. Now in DC, we know that the frequency is 0 in case of DC. Therefore, omega will also be 0. Okay, and XL is equal to omega into L. So this will also be 0 because omega is 0. So here in the first circuit, the value of XL is 0. R is given as 10 ohm. So what will be the impedance? That means Z1, that will be equal to under root R square plus XL square, but XL is 0, so that will be equal to R square only. Okay. Now if we talk about the second circuit, this is an AC circuit. Okay. So here frequency is not 0. Okay. Frequency is not 0. Therefore, there will be certain value of XC. Okay. XC will not be 0 here. So here the impedance, that means Z2 will be equal to under root R square plus XC square. Okay. Now R is same in both the cases, so its value will be same in both. But in the second case, there is an additional component XC square which is absent in the first case. So which impedance should be greater? In the second case, impedance should be greater. Okay. So Z2 should be greater than Z1, or we can say Z1 should be less than Z2. Okay. Because in Z1 we have only R square, but in Z2 we have R square as well as XC square. So according to that, option A will be the correct answer. Question number 28 is from the chapter Atoms, and the question is the wavelength of Lyman series of hydrogen atom appears in option A visible region, option B far infrared region, option C ultraviolet region, and option D infrared region. So this is very easy. We know that the wavelength of Lyman series of hydrogen atom appear in the UV region. Okay, that means ultraviolet region. For Balmer series, the wavelength appears in the visible region, whereas for all the other series, the wavelength lies in the infrared regions. Okay, so here it is asked about the Lyman series, so the answer will be ultraviolet region. Option C will be the correct answer. Question number 29 is from the chapter Semiconductor Electronics, and the question is the above figure shows the circuit symbol of a transistor. Select the correct statements given below. The first statement says the transistor has two segments of p-type semiconductor separated by a segment of n-type semiconductor. Second statement says that the emitter is of moderate size and heavily doped. Third statement says that the central segment is thin and lightly doped. And the last statement says that the emitter base junction is reverse biased in common emitter amplifier circuit. So first of all, the first statement is saying that it is a PNP type of semiconductor, okay? Two P-type semiconductors separated by a N-type semiconductor. But if you look at this figure, here arrow shows the direction of electric current. So from this figure, we can say that the emitter current leaves the emitter. Therefore, this is an NPN type of semiconductor, not PNP. Therefore, the first statement will be incorrect. Now for second and third statement, we should know the order of doping. Order of doping and order of size. Order of size. So this you should remember. Emitter is always heavily doped. Okay. After that, collector. And then base region has the minimum doping. Okay. If we talk about the size, although emitter is most heavily doped, but its size is less than that of collector region. So collector has the maximum size, then emitter, and then base. So base has both minimum doping as well as minimum size. Now the second statement is saying that the emitter is of moderate size. So yes, size of emitter is moderate, but it is heavily doped. So doping is maximum. This is a correct statement. The third statement is saying that the central segment is thin and lightly doped. So this is your emitter region, this is your base region, and this is your collector region. Okay. Size of the collector region is maximum, but doping is maximum in emitter region. The base region is the thin and lightly doped region. Okay. So option C, the statement C will also be correct. Then the last statement says the emitter base junction is reverse biased in common emitter amplifier circuit. So this is incorrect because we know that for active mode, the emitter base junction is always forward bias. Okay. Junction is always forward biased. It is not reverse bias. So this last statement is incorrect. We have to find out the correct statements. So B and C are correct statements. Option D will be the correct answer. Question number 30 is from the chapter Atoms, and the question is the de Broglie wavelength associated with an electron accelerated by a potential difference of 81 volt is given by. Okay. So we know that the de Broglie wavelength of an electron is equal to 12.27 divided by root V angstrom. V is the potential difference. So let's put the value 12.27 divided by root V. V is 81 volts, so root V will be 9. Okay. And the unit will be angstrom. So here on solving this, we'll get 1.36 angstrom. 1.36 angstrom. But in the options, we have nanometer, not angstrom. So for that, we know that 1 angstrom is equal to 0.1 nanometer. So to convert it into nanometer, we have to multiply it by 0.1 into 0.1 nanometer. So on solving this, we'll get 0.136 nanometer. Option D will be the correct answer. Question number 31 is from the chapter Alternating Current, and the question is the maximum power is dissipated for an AC in a. Options are resistive circuit, LC circuit, inductive circuit or capacitive circuit. Okay, so we know that power dissipated is maximum in case of purely resistive circuit. Okay, whereas for others these are used to store power. They store power, whereas resistive circuit dissipates power. Okay, dissipates or loses. So option A will be the correct answer. Question number 32 is from the chapter Dual Nature of Radiation and Matter, and the question is the maximum kinetic energy of the emitted photoelectrons in photoelectric effect is independent of option A work function of the material, option B intensity of incident radiation, option C frequency of incident radiation, and option D wavelength of incident radiation. So we know that the maximum kinetic energy, that is K max, is equal to kinetic energy minus phi. Phi is the work function here. It is the work function. Now this energy can be written as h mu, that means Planck's constant into frequency, or it can be written as hc by lambda. Now here in the first option, work function of the material is given. We can see that the kinetic energy, maximum kinetic energy, is depending on the work function phi. So it is not independent of the work function. So this is not correct. The second one is intensity of the incident radiation. Yes, it is independent of the intensity of incident radiation. Third one is frequency of incident radiation. So here we can see that it is depending on the frequency. Okay, here we have frequency. So it depends on frequency. It is not independent of frequency. So this cannot be correct. And it is also depending on the wavelength by using this formula. So option D is also wrong. The only correct option is option B. Question number 33 is from the chapter Systems of Particles and Rotational Motion, and the question is two particles A and B initially at rest move towards each other under mutual force of attraction. At an instance when the speed of A is v and the speed of B is 3v, the speed of center of mass is. So we know that the initial momentum, total initial momentum is always equal to the total final momentum by the law of conservation of momentum, right? Now here in the question it is given that we have two particles, both of them initially were at rest. That means initially the velocity of the center of mass will also be 0 because the velocity of each of the particles is 0. Okay, and they start moving towards each other under mutual force of attraction. That means there was no external force applied to them. Okay, so external force is 0. That means the momentum will also be the initial momentum and both the final momentum will be 0. So we can say that the final velocity of the center of mass will also be 0. So option B will be the correct answer. Question number 34 is from the chapter Electric Charges and Fields, and the question is a charge q microcoulomb is placed at the center of a cube. The flux coming out from any one of its faces will be in SI unit. Okay. So what is the total flux? The total flux from the cube will be equal to the given charge upon epsilon naught. Okay. We have to find out the flux coming out of any one surface of cube. Okay, any one of its faces. That will be equal to given charge upon 6 epsilon naught. Given charge is q microcoulomb, that means q into 10 to the power minus 6 coulomb. Okay, so let's put the value q into 10 to the power minus 6 upon 6 epsilon naught. Okay, so this is the answer. Here we can see in option D we have the correct answer. Okay, q by 6 epsilon naught into 10 to the power minus 6. Option D will be the correct answer. Question number 35 is from the chapter Mechanical Properties of Fluids, and the question is the viscous drag acting on a metal sphere of diameter 1 millimeter falling through a fluid of viscosity 0.8 Pascal second with a velocity of 2 meter per second is equal to. Okay. So viscous drag we have to find out. That means we have to find out the viscous force acting on the metal sphere. So what is the formula for viscous force? That is equal to 6 into pi into viscosity into radius into velocity. Okay. 6 into pi. What is the value of pi? 3.14. Then viscosity is given as 0.8 Pascal second, 0.8 Pascal second. Then radius. So diameter is given as 1 millimeter. That means 10 to the power minus 3 meter. So what will be the radius? Half of this. That means 10 to the power minus 3 divided by 2. And then we have velocity that is given as 2 meter per second. So this 2 will be cancelled. Now on solving this, we'll get 15 into 10 to the power minus 3 and the unit of force will be Newton. So option A will be the correct answer. Question number 36 is from the chapter Gravitation, and the question is, if r is the radius of the earth and g is the acceleration due to gravity on the earth's surface, then the mean density of the earth will be. So it's very easy. We know that the acceleration due to gravity is equal to gm upon r square. Okay, capital G is the gravitational constant, m is mass of the earth, and r is the radius. Okay, now here we have to find the mean density, so we'll convert mass in terms of density. Okay, we know that mass by volume is equal to density, right? So mass will be equal to volume into density. So in place of mass we can put volume into density, right? So let's write it down here. We have the gravitational constant G into volume, that is equal to 4 by 3 pi r cube. Okay, this is the volume of the sphere, that is earth, into density, right? We have put volume into density in place of mass, divided by r square. This side we have small g, that means acceleration due to gravity. So this r square will cancel 2r here, only 1r will be left, right? So what will be left here? Capital G into density into 4 by 3 pi r. So we have to find out the density rho. So rho will be equal to 3 small g upon 4 pi r, and capital G will also be there. So this will be the mean density of the earth. So let's see which option suits best. Option C will be the correct answer. Question number 37 is from the chapter Current Electricity, and the question is, a copper wire of radius 1 millimeter contains 10 to the power 22 free electrons per cubic meter. The drift velocity for free electrons when 10 ampere current flows through the wire will be. It is given that charge on the electron is 1.6 into 10 to the power minus 19 coulomb. Okay. So we know that the current I is equal to NEA VD, where N is the number of electrons, then E is the electronic charge, that means charge on an electron, A is the area, and VD is the drift velocity. Okay, so we have to find out the drift velocity, that means VD. So that will be equal to I divided by N into E into A. So let's put the values. The current is given as 10 ampere. So 10 divided by number of electrons is 10 to the power 22. Then charge on an electron is 1.6 into 10 to the power minus 19 coulomb. Then we have area. Area means pi r square. So pi. And here radius is given. R is given as 1 millimeter. That means 10 to the power minus 3 meter. So r square will be 10 to the power minus 6 meter square. Okay. So here we'll write 10 to the power minus 6. Now if you solve this, you will get 6.25 upon pi into 10 to the power 3 meter per second. This will be the drift velocity on solving this. So the correct answer will be option number B. Question number 38 is from the chapter Ray Optics and Optical Instruments, and the question is, an object is mounted on a wall. Its image of equal size is to be obtained on a parallel wall with the help of a convex lens placed between these walls. The lens is kept at a distance x in front of the second wall. The required focal length of the lens will be. So we have a wall here, an object is mounted here, okay, on this wall. Then we have a parallel wall here. The image has to be obtained of equal size and a convex lens is kept between these two walls, okay. Now we know that an image of equal size will be formed only when the object is kept at a distance 2f from the lens, okay. If this is your f focal length, then the object has to be kept at a distance 2f. Then only an image of equal size will be formed, okay. So this image will also be formed at the distance 2f, right. Now it is given that the lens is kept at a distance x in front of the second wall. That means it is given that this distance is x. That means 2f is equal to x. So what should be the focal length f? That will be equal to x by 2. This is the only condition under which an image of equal size will be formed by a convex lens. So the focal length should be equal to x by 2. Option C will be the correct answer. Question number 39 is from the chapter Electric Charges and Fields, and the question is, if a conducting sphere of radius r is charged, then the electric field at a distance r, where r is greater than the radius, from the center of the sphere would be. V is the potential on the surface of the sphere, okay. So we have a conducting sphere. This is your conducting sphere, okay. This is the radius capital R. We have to find out the electric field at a distance small r, which is greater than the radius, okay. At this point, say point P, we have to find out the electric field, okay. Potential on the surface of the sphere is given as V. We know that potential is equal to K into Q upon R radius, okay. This is the formula for potential on the surface. So from here we can say that kq will be equal to v into r from the formula of potential. Now we have to find out the electric field. So electric field, net electric field at the distance small r will be equal to kq upon square of small r, okay. And we know that kq is equal to vr, so we can put that value vr upon small r square. So this will be the value of electric field at a distance small r from the center of the sphere, okay. So it will be option number C. Don't confuse between option A and option C. In option A we have radius square here, but in option C we have this distance square. So option C will be the correct answer. Question number 40 is from the chapter Friction, and the question is, a block of mass 2 kg is placed on inclined rough surface AC of coefficient of friction mu. If G is equal to 10 meter per second square, the net force in Newton on the block will be, okay. So the coefficient of friction mu is given as 1 by root 3 in this figure, okay. Here you can see it is 1 by root 3. Now let's find the angle of repose. We know that mu will be equal to tan theta r, that means angle of repose. So mu is given as 1 by root 3, that means tan theta r is equal to 1 by root 3. So from here we can say that the angle of repose is 30 degree, because tan 30 degree is equal to 1 by root 3, okay. So this is angle of repose, and here the angle of this inclined surface is also 30 degree, okay. Theta is equal to 30 degree. Now we know that when theta is less than or equal to the angle of repose, in that case the block will not move. So we can say that the block is at rest, So since the block is at rest, we can say there is no net force acting on it, okay. So net force is 0 here. Option B will be the correct answer. Next question is, a container of volume 200 centimeter cube contains 0.2 mole of hydrogen gas and 0.3 mole of argon gas. The pressure of the system at temperature 200 Kelvin will be, okay. The value of gas constant is given 8.3 joule per Kelvin per mole. So we have 0.2 moles of hydrogen, this is N1. Then we have 0.3 moles of argon gas, this is N2. We have to find the pressure of the system. So pressure will be equal to total number of moles, that means N1 plus N2 into R into T upon volume V. We just have to put the values. N1 is 0.2, N2 is 0.3, then gas constant is 8.3, temperature is 200 Kelvin divided by volume. So volume is given as 200 centimeter cube. In meter cube, it will be 200 into 10 to the power minus 6 meter cube, right? So let's put this value 200 into 10 to the power minus 6 meter cube. This 200 will be cancelled. Now on solving the rest, we'll get 4 into 10 to the power 6 and the unit of pressure will be Pascal. So the correct answer will be option D. Okay, this will be the most appropriate answer. Question number 42 is from the chapter Electrostatic Potential and Capacitance, and the question is, to produce an instantaneous displacement current of 2 milliampere in the space between the parallel plates of a capacitor of capacitance 4 microfarad, the rate of change of applied variable potential difference dV by dt must be. Okay, so displacement current is given as 2 milliampere. That means 2 into 10 to the power minus 3 ampere, right? And capacitance C is given as 4 microfarad. That means 4 into 10 to the power minus 6 farad, right? Now we have to find the rate of change of applied potential difference, that means dV by dt. So for that we know that Q is equal to C into V. Okay, charge is the product of capacitance and potential. If we differentiate both sides, we'll get dq by dt this side, and this side will get C dV by dt. Now this dV by dt we have to find out. dq by dt is nothing but the current. So this is the displacement current or the conduction current, that is equal to C dV by dt. Now we'll put the values and find the value of dV by dt. So dV by dt will be equal to Id divided by C, capacitance. So Id, that means the displacement current, is given as 2 into 10 to the power minus 3 ampere, and the capacitance is given as 4 into 10 to the power minus 6 farad. On solving this, we'll get 500 and the unit will be volt per second. So option B will be the correct answer. Question number 43 is from the chapter Alternating Current, and the question is, an EMF is generated by an AC generator having 100 turn coil, a loop area 1 meter square. The coil rotates at a speed of 1 revolution per second and placed in a uniform magnetic field of 0.05 Tesla, perpendicular to the axis of rotation of the coil. The maximum value of EMF is, okay. So what is given in the question? Number of turns, that means N is given as 100. Loop area is given as 1 meter square. Then we have omega, 1 revolution per second, okay, and we know that omega is equal to 2 pi radian per second. 2 pi radian per second, it is given as 1, that means that will be equal to 2 pi only, okay. Omega is equal to 2 pi. Then we have magnetic field B equals to 0.05 Tesla. These things are given in the question. We have to find out the maximum value of EMF. So maximum EMF will be equal to, we know the formula, NBA omega. Okay, this is the simple formula. N is the number of turns, that is 100. B is the magnetic field, 0.05 Tesla. Area is 1 meter square and omega is equal to 2 pi, that means 2 into 3.14. On solving this, you will get 31.4 and the unit of EMF is volt. So 31.4 volt, that means option B will be the correct answer. Question number 44 is from the chapter Alternating Current, and the question is, for very high frequencies, the effective impedance of the circuit will be. So we know that at very high frequencies, what happens to the capacitor? The capacitor gets short circuited. Okay, it gets short circuited. So the value of Xc is almost 0. And what happens to the inductor at very high frequencies? Inductor starts behaving as an open circuit. It behaves as an open circuit. So what is the value of XL? Infinite. So here the inductor we have to ignore and the capacitor should also be ignored. So the effective circuit that we can draw here is this one, 1 ohm resistance. Then here we have 2 ohm resistance. This is your effective circuit. So impedance of this circuit will be 1 ohm plus 2 ohm, that means 3 ohm. The answer will be 3 ohm. Option D will be the correct answer. Question number 45 is related to rotational motion, and the question is a constant torque of 100 Newton meter turns a wheel of moment of inertia 300 kg meter about an axis passing through its center. Starting from rest, its angular velocity after 3 seconds is. So it had started from rest, that means initial angular velocity was 0. We have to find the final angular velocity after 3 seconds, right? Now we know that torque is equal to I into alpha. I is the moment of inertia and alpha is the angular acceleration. So from here, alpha will be equal to torque divided by moment of inertia. Torque is given as 100 Newton meter and moment of inertia is given as 300 kg meter. So here we'll get 1 by 3 and the unit of angular acceleration will be radian per second square. Okay. So now we have to find out the final angular velocity, that will be equal to initial angular velocity plus alpha into t. So that will be equal to 0 because initial angular velocity is 0 plus alpha is 1 by 3 and time given is 3 seconds. So this will be equal to 1. Okay, and the unit of angular velocity will be radian per second. So 1 radian per second will be the answer. Option number A. Question number 46 is from the chapter Current Electricity, and the question is the EMF of a cell having internal resistance 1 ohm is balanced against a length of 330 centimeter on a potentiometer wire. When an external resistance of 2 ohm is connected across the cell, the balancing length will be. Okay, so internal resistance, that means small r is 1 ohm. External resistance is 2 ohm, so capital R is 2 ohm. Now the length of the open circuit is 330 centimeter. Okay, so length open is 330 centimeter. We have to find the balancing length after the external resistance is connected. So we have to find the length of the closed circuit. So we know the formula, small r is equal to length of open circuit minus length of closed circuit upon length of closed circuit into capital R, that is external resistance. So we just have to put the values. Internal resistance is 1 ohm. Here we have length of open circuit, that is 330 centimeter. The length of closed circuit we don't know, we have to find out, into the external resistance, that is 2 ohm. Okay. So here we get length of closed circuit equals to 660 minus 2 length of closed circuit. So 3 times length of closed circuit is equal to 660 centimeter. So the length of closed circuit will be 660 divided by 3 centimeter, that means 220 centimeter. So option A will be the correct answer. Question number 47 is from the chapter Laws of Motion, and the question is a 1 kg object strikes a wall with velocity 1 meter per second at an angle of 60 degree with the wall and reflects the same angle. If it remains in contact with the wall for 0.1 second, then the force exerted on the wall is. Okay, so we have a wall here. Then an object of 1 kg strikes the wall with a velocity of 1 meter per second, making an angle of 60 degree with the wall. Okay, so 60 degree with the wall, that means this angle is 60 degree. Then it reflects back at the same angle, so this angle is 60 degree. Right? We have to find the force exerted on the wall. We know that force is equal to rate of change of momentum. So delta P by delta T. So we have to find the change of momentum. So if we talk about the direction of the object before and after reflection, okay, before it strikes the wall, it is moving towards the downward direction, and after reflection also it is moving in the downward direction. So is there any change in the vertical direction? No, there is no change in the vertical direction. There is no change in the vertical direction. If we talk about the horizontal direction, then before striking the wall it was moving towards right side, but after reflection it is moving towards left side. Okay, before this is the direction, after this is the direction. So there is a change in the horizontal direction. There is a change in the horizontal direction, but there is no change in the vertical direction, because before and after it is moving downward only. Okay, so we have to consider the horizontal direction only. Now if we resolve the components, here we will have mv sine theta, here we'll have mv cos theta. Okay, similarly after reflection also we have this mv sine theta, and this side we have mv cos theta. So since there is no change in the vertical direction, so mv cos theta will be ignored and mv sin theta will be considered. Okay, so what will be the change of momentum? It will be mv sin theta minus mv sin theta, because there is change in horizontal direction. Okay, now after reflection it is moving in the opposite direction, so it will be minus mv sin theta divided by delta t. So on the numerator side we'll get 2mv sin theta, and denominator side will get delta t. Now we can put the values. 2m, what is the mass of the object? It is 1 kg. Velocity is 1 meter per second. Then sine theta, theta is 60 degree. So sine 60 degree will be equal to root 3 by 2. And then on the denominator side we have delta t, that is equal to 0.1 second. 0.1. So if we solve this, we'll get 10 root 3 and the unit of force will be Newton. So option C will be the correct answer. Question number 48 is from the chapter Atoms, and the question is: the angular momentum of an electron moving in an orbit of hydrogen atom is 1.5 h by pi. The energy in the same orbit is nearly. Okay, so we know that the angular momentum is given by the formula mvr. Okay, this is the formula for mvr, and that is equal to nh by 2 pi. Okay, now its value is given in the question. It is given as 1.5 h by 2 pi, sorry, h by pi. Okay, so if we compare these two parts, from here h by pi are both sides, so from here we can say that the value of n will be equal to 1.5 into 2, that is 3. So now we have got the value of n, and we have to find the energy in the same orbit. That means energy in n equals to 3. So what is the formula for energy? That is equal to minus 13.6 by n square electron volt for hydrogen atom. Okay, because for a hydrogen atom the value of Z is 1. Therefore Z will not be included in this formula. We can simply write minus 13.6 by n square for hydrogen atom only. Okay, so minus 13.6, and we have found the value of n, that is 3. So n square will be 9. The unit will be electron volt. So on solving this you will get minus 1.5 electron volt. This will be your answer. Option number A will be the correct answer. Question number 49 is from the chapter Motion in a Plane, and the question is: a particle is executing uniform circular motion with velocity vector v and acceleration vector a. Which of the following is true? Option A: vector v is a constant, vector a is not constant. Option B: vector v is not constant, vector a is not a constant. Option C: vector v is a constant, vector a is also a constant. And option D: vector v is not a constant but vector a is a constant. So we know that in case of a uniform circular motion, both velocity and acceleration change. Both velocity and acceleration change. Although the magnitude of acceleration remains same, but the direction will change, so it will not be constant. These two will not be constant. Okay, none of them is constant. So we can say that vector v is not a constant and vector a is also not a constant. Option B will be the correct answer. And now the last question is from oscillations, and the question is: a simple pendulum oscillating in air has a period of √3 seconds. If it is completely immersed in non-viscous liquid having density 1/4 of the material of the bob, the new period will be. So we are talking about the time period, right? We know that time period in air is equal to 2 pi under root L by g. G is the acceleration due to gravity. And what happens in liquid? The time period in liquid is equal to 2 pi under root L by G net. What is G net? G net is equal to G1 minus density of the liquid by density of the object. Okay. So in liquid, the time period is equal to 2 pi under root L by G net. G net means G into 1 minus the density of the liquid by density of the material of the bob or the object. Okay. So if we compare it with the time period of the air, we can write that time period in liquid is equal to the time period in air divided by under root 1 minus the density of the liquid by density of the material of the bob or the object. Okay. So simply now we have to put the values. What is the time period in air? It is given as √3. Then here we have 1 minus density of the liquid is 1/4 of the material of the bob. That means if the density of the bob, material of the bob is 1, then the density of the liquid will be 1/4. So here we'll get 1/4. Okay, 1 by 4. Now on solving this further, we get √3 by, here we'll get √3 by 2. Okay, so this 2 will go up here. So √3 will be cancelled. We'll get 2 seconds. This will be the time period in liquid. Okay. So option C will be the correct answer. So here we complete all the physics questions from NEET 2023 Manipur paper. We'll be back with another session soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice same questions from our website www.examsnet.com. And for more information, download our app from the link given in the description. Thank you so much. Hey champs of Examsnet, welcome to the question series of Examsnet. I hope this series of detailed explanation is helping you a lot. So in today's session, we are going to discuss chemistry questions from NEET 2023 Manipur paper, and we are 50 questions here. So let's start the session. The first question is from the chapter Structure of an Atom, and the question is: incorrect set of quantum numbers from the following is. Okay. So in the first option, we have n equals to 4. So the principal quantum number is 4. And then the azimuthal quantum number L is equal to 3. So is it possible? We know that the value of L can be from 0 to n minus 1. Okay. So if n equals to 4, then the value of L can be from 0 to 4 minus 1, that is 3. It can lie anywhere between 0 to 3. So yes, L equals to 3 is possible, right? Now m, what will be the value of m? That will be equal to, that will be from minus L to plus L. Okay. So if the value of L is 3 here, then what can be the values of m? It can be minus 3, then minus 2, then minus 1, then 0, then plus 1, plus 2 and plus 3. Okay, from minus 3 to plus 3. So yes, these are given here, and then the spin quantum number is minus half. So it can be minus half or plus half, anything. So this is correct. Okay, but we have to find out the incorrect set. Now let's come to the second one. Here n is equal to 5. So when n equals to 5, then L can be from 0 to 5 minus 1, that is 4. So here the value of L is 2. Now if the value of L is 2, then what will be the values of m? It will be from minus 2 to plus 2, right? That means minus 2, then minus 1, then 0, then plus 1, then plus 2. These are the values of m. So here minus 2 is given, minus 1 is given, but 0 is not given. Okay, 0 should also be there. So this is incomplete. After that, plus 1 and plus 2 will come. So this seems to be incorrect. Let's see other options. In the next option, the value of N is 4. The value of L is 2. So yes, 2 is possible because it is from 0 to 3. Okay. Then the value of M for L equals to 2. For L equals to 2, what will be the values of M? It will be from -2 to +2, right? That means it will be -2, then -1, then 0, then +1, then +2. Yes, this is correct. And the spin quantum number will be -half or +half, anything. So this is also correct. Then in the last one we have N equals to 5, L equals to 3. So the value of M will be from -3 to +3. So -3, -2, -1, then 0, then +1, then +2, +3. And then spin quantum number will be +half. So this is also possible. The only incorrect one is the second option where 0 is missing. Okay. So option B will be the answer here. Question number 52 is from the chapter D and F block elements, and the question is given below are two statements. One is labeled as assertion and the other is labeled as reason. So let's read the assertion. It says ionization enthalpy increases along each series of the transition elements from left to right. However, small variations occur. So this is a correct statement. Okay. The ionization enthalpy keeps on increasing as we move from left to right. The reason mentioned here is there is corresponding increase in the nuclear charge which accompanies the filling of electrons in the inner d orbitals. So this is also correct. Okay. And this is the exact reason for the assertion mentioned here. Okay. Because there is increasing nuclear charge as we move from left to right, the electrons are filled in the inner d orbitals. Okay. So they are held tightly, and this is the reason why their ionization enthalpy keeps on increasing on moving towards the right. Okay. So both assertion and reason are correct, and reason is the correct explanation of assertion. Option C will be the correct answer. Question number 53 is from the S block elements, and the question is given below are two statements. One is labeled as assertion and the other is labeled as reason. So the assertion says that lithium and beryllium, unlike their other respective group members, form compounds with pronounced ionic character. So this is an incorrect statement because the compounds formed by lithium and beryllium are of covalent character. Okay, they have covalent character, not ionic character. So this is incorrect. Then the reason here is lithium and magnesium have similar properties due to diagonal relationship. So this is correct. Okay, this is a fact that lithium and magnesium share similar properties due to diagonal relationship. So the first statement, that means assertion, is false, but reason is true. So option B will be the correct answer. Question number 54 is from the chapter equilibrium, and the question is for a weak acid HA, the percentage of dissociation is nearly 1% at equilibrium. If the concentration of acid is 0.1 mole per liter, then the correct option for its Ka at the same temperature is. Okay. So the percentage of dissociation is 1%. That means the degree of dissociation alpha is equal to 0.01, right? Now the concentration of the acid C is equal to 0.1 mole per liter. We have to find Ka. So Ka will be equal to C alpha square, right? So the value of C is 0.1, alpha is 0.01. That means square will be 0.01 square. So here it will be 10 to the power minus 1 into 10 to the power minus 4. So it will be 10 to the power minus 5. Or we can say 1 into 10 to the power minus 5. That means option C will be the correct answer. Question number 55 is from the chapter solution, and the question is the density of 1 molar solution of a compound X is 1.25 grams per ml. The correct option for the molality of the solution is molar mass of the compound X is given as 85 grams. Okay. So here if we talk about the molarity, it is given in the question that it is 1 molar solution. That means molarity is given as 1 molar, and we know that molarity is nothing but the number of moles of solute divided by the volume of the solution, right? So number of moles of solute divided by the volume of solution in liter. Okay. So that is given as 1 molar. So from here we can say that the number of moles of solute is equal to 1. Okay, 1 mole of solute is dissolved in 1 liter of the solution. Okay, so the volume is 1 liter, or we can say 1000 milliliter. So N is equal to 1 and volume of the solution is 1000 ml. Now we know that the density of the solution is given. Of the solution is given as 1.25 gram per ml. So from here we can find the mass of the solution. Mass of the solution will be equal to volume into density, right? Volume of the solution is 1000 ml and the density of the solution is 1.25 grams per ml. So what will be the mass of the solution? It will be 1250 grams. So now we have got the mass of the solution, but to find out the molality, we should know the mass of the solvent, not solution. So for that, we'll find out the mass of the solvent. We know that the mass of solute, what is solute? Solute is nothing but the compound X that we are talking about, plus mass of solvent together give the mass of the solution, right? Mass of solution. In the question, mass of solute is given 85 grams. So mass of solute, that is compound X, is 85 grams. Mass of solvent is unknown, that we have to find out. Mass of solvent, that is equal to mass of the solution, that means 1250 gram. So what will be the mass of solvent? Mass of solvent will be equal to 1250 minus 85 grams. That means 1165 grams. This is the mass of the solvent. Now we can easily find out the molality. We know that molality is equal to numbers of moles of solute divided by the mass of solvent in kg. Mass of solvent in kg. Now what was the number of moles? Number of moles of solute was 1, right? So 1 divided by mass of solvent, that is equal to 1165. But this is in grams, we have to convert it into kg. So it has to be divided by 1000. So 1000 will go up here. So it will be 1000 by 1165, and on solving this we'll get 0.858. This will be the molality. Okay. So option D, 0.858 molal will be the correct answer. Question number 56 is from the chapter Alcohols, Phenols and Ethers. Here a reaction is given where acetone is being treated with dilute barium hydroxide to give a compound X. Now it is asked that the functional groups present in the compound X are. Okay. So we know that when acetone is treated with barium hydroxide, it gives diacetone alcohol. Okay. It gives diacetone alcohol. This is the product that will be obtained here. So in this reaction, what happens? Two molecules of acetone condense. Okay. So it is an example of aldol condensation reaction. Aldol condensation reaction. Let's see the structure of diacetone alcohol. So it will be CH3, then C. Here we have hydroxyl group OH, CH3, then we have CH2, C double bond O, and then CH3. Okay, this is your diacetone alcohol, that is the product X. So here you can see we have, what are the functional groups here? An alcohol and a ketone. So option D will be the correct answer. Question number 57 is from the chapter Electrochemistry. Here the E0 values are given and we have to identify the incorrect statement. Let's read the statement. The first statement says aluminium is more electropositive than thallium. So this is a common fact that aluminium is more electropositive than thallium, because we know that whenever we move from aluminium to thallium down the group, then the electropositive character decreases, right? So aluminium will be more electropositive. So this is a correct statement. But we have to identify the incorrect statement. So let's come to the second statement. It says thallium 3 plus is a good reducing agent than thallium 1 plus. So if we compare the reduction potentials of thallium 3 plus with that of thallium plus. So for thallium 3 plus, the reduction potential is plus 1.26 volt, whereas for thallium plus, it is minus 0.34 volt. So in which case it is more? It is more in case of thallium 3 plus. That means thallium 3 plus will get reduced easily. It will get reduced easily. That means it will act as a oxidizing agent. Act as an oxidizing agent. Because itself it is getting reduced, so it will act as oxidizing agent for others. That means thallium 3 plus is a good oxidizing agent than thallium plus, not reducing agent. So this is the incorrect statement. Therefore option B will be the correct answer. Okay. Question number 58 is from the chapter Chemical Bonding and Molecular Structure, and the question is the correct order of dipole moments for molecules NH3, H2S, CH4 and HF is. Okay. So we know that more the electronegativity difference, electronegativity difference, more will be the dipole moment. Okay. More is the dipole moment. So here you can see that one of the atoms in each molecule is hydrogen. So we have to see which one has maximum electronegativity difference with hydrogen. So which is the most electronegative atom? Fluorine is the most electronegative atom. So the maximum difference will be in case of hydrogen fluoride. So HF will have the maximum dipole moment. After that, nitrogen. So NH3 will come next. Then next will be your H2S, and the least electronegativity difference is in case of methane. So CH4 will have the minimum dipole moment. Therefore, the correct answer will be option number D. Question number 59 is from the chapter Electrochemistry, and the question is molar conductance of an electrolyte increase with dilution according to the equation. So here we have this equation. This is Debye-Huckel equation. Okay, Debye-Huckel equation. And this equation is applicable to the strong electrolytes. Strong electrolytes. Now let's see the statements. The first statement says this equation applies to both strong and weak electrolytes. So this is incorrect because this is applicable only to strong electrolytes, not weak electrolytes. Then come to the second statement. It says value of the constant A depends upon the nature of the solvent. Yes, the value of this constant A depends upon the nature of the solvent. And then it also depends on the nature of the solute. Okay. Then we come to the third statement. Value of constant A is same for both BaCl2 and MgSO4. So BaCl2, what is the charge on barium here? Ba2 plus. Okay, this is the cationic charge, 2 plus. And for chlorine, it is -1. Okay. And if we talk about MgSO4, here what is the charge on the cation? Magnesium. It will be Mg2 plus. And then on sulfate, it will be -2. Okay. So if we compare the cationic charge in both the compounds, it is same, +2. But if we compare the anionic charge, it is different. It is -1 in case of chloride and it is -2 in case of sulfate. So this is not same. So they will not have the constant value of A. Okay. So this is incorrect statement. Let's come to the last statement. It says value of constant A is same for both BaCl2 and MgOH2. So again we'll compare the cationic and anionic charge. Okay, BaCl2 and MgOH2. So the charge on barium is +2 and charge of magnesium is also +2. Okay. Then charge on the anion chloride is -1 and charge on the anion in the second compound OH is also -1. Okay, it is OH -1. So here if we compare the charge on cations in both the compounds, it is same +2, and the charge on anions is also same -1 in both the cases. So yes, they will have a constant value of A. So statement D is correct. So we have two statements which are correct. These are B and D. So option D will be the correct answer, B and D only. Question number 60 is from the chapter Biomolecules, and the question is chylosis occurs due to the deficiency of. Options are thiamine, nicotinamide, pyridoxamine, and riboflavin. So this is a factual question. We know that chylosis occurs due to the deficiency of vitamin B2. And another name of vitamin B2 is riboflavin. Okay, riboflavin. What happens in chylosis? The fissuring at the corners of the mouth and lips. Okay, so fissuring at corners of mouth and lips. This is the sign of chylosis. So the correct answer will be option number D, riboflavin. Question number 61 is from the chapter Electrochemistry, and the question is the correct value of cell potential in volt for the reaction that occurs when the following two half cells are connected is. So we have two half cells. This is the first half cell and this is the second half cell. Okay. Now if you look carefully, you can see that in both the equations, electrons are being accepted. Okay. That means in both the cases, reduction potentials are given. Okay, in the first case the reduction potential is minus 0.44 volt, and in the second case it is plus 1.33 volt. But we have to consider that in one of the equation reduction is taking place and the other equation oxidation is taking place. Okay, so we have to compare the reduction potential. In which case it is more? It is more in the second case. Okay, this is more, this value of reduction potential is more. That means we will consider that reduction is taking place here. Reduction is taking place. And we know that reduction takes place at the cathode. So the second equation is the reaction that is taking place at the cathode, and therefore the first reaction will take place at the anode, right? Now we have to find out the correct value of cell potential for the cell when these two are connected. So the cell potential E naught cell will be equal to the electrode potential at the cathode, E naught cathode minus E naught anode. Okay, this is the simple formula. So what is the value of E naught cathode? The second equation, that means 1.33 volt, minus what is the value of E naught anode? The first equation, that means minus 0.44. So minus 0.44. Now if we solve this, we'll get 1.33 plus 0.44 volt, and on solving this we'll get plus 1.77 volt. That means option A will be the correct answer. Question number 62 is from organic chemistry. Here two reactions are given and we have to identify X in the above reactions. So by mistake here the X is already given in the question. Okay, here in place of this reagent X letter was there. Okay, this reagent was indicated by X and we had to identify that, but it is already given here. It is diborane B2H6. Okay, so even if it was not given, you should understand that diborane can convert acid into the corresponding alcohol. Okay, and then it can also convert an alkene into the alcohol by hydroboration oxidation reaction. Okay, so these two reactions are shown here and the letter X is nothing but B2H6. Option A will be the correct answer. Question number 63 is from the chapter Chemical Kinetics, and the question is for a reaction 3A to 2B, the average rate of appearance of B is given by delta B by delta T. The correct relation between the average rate of appearance of B with the average rate of disappearance of A is given in option. Okay. So here we know that the reactant will disappear and the product will appear. So reactant here is A, that means A will disappear. So what will be the rate of disappearance disappearance of A, it will be delta A by delta T. And what will be the rate of appearance of B? Appearance of B, it is given in the question, delta B by delta T, right? Now, we have to find the relation between the appearance of B and the disappearance of A, okay? The rate of these two. So we know that the rate of the rate of the reaction is equal to the rate of disappearance of the reactant divided by the coefficient, okay? So it is equal to the, okay, there will be a minus sign in the rate of disappearance because its amount is decreasing, so there will be a minus sign. So minus delta A by delta T divided by the coefficient, so 3, okay? And that will be equal to the rate of appearance of B divided by its coefficient, stoichiometric coefficient. So it will be equal to delta B by delta T divided by 2, okay, because its stoichiometric coefficient is 2. So these two will be equal. Now we can find the relation between rate of appearance of B with the average rate of disappearance of A. So delta B by delta T will be equal to 2 will come this side. So it will be minus 2 delta A divided by 3 delta T. So this will be the required relation. So let's see, we have minus 2 by 3 delta A by delta T. Option C will be the correct answer. Question number 64 is from the chapter Aldehydes, Ketones and Carboxylic Acids, and the question is the following conversion is known as. So here we can see that this is an acyl chloride, okay? Acyl chloride. It is undergoing reduction, okay, because it is reacting with hydrogen in the presence of palladium as catalyst, okay, that is poisoned with barium sulfate. So it will give an aldehyde, right, according to this reaction. So this reaction is nothing but the Rosenmund reduction reaction. What happens in Rosenmund reduction? Acyl chlorides are selectively reduced into aldehyde in the presence of palladium catalyst that is poisoned with barium sulfate. So option D will be the correct answer. Question number 65 is from the chapter Chemistry in Everyday Life, and the question is which amongst the following is used in controlling depression and hypertension? Options are Sildane, Valium, Equanil and Prontosil. So this is a factual question. Again, we know that the drug Equanil is used to control depression and hypertension. So option C will be the correct answer. Question number 66 is from the chapter Classification of Elements and Periodicity in Properties. And the question is which one of the following represents all isoelectronic species? That means these species having same number of electrons. Okay, same number of electrons. So we know that the number of electrons is equal to the atomic number. So if you remember the atomic number of all the elements, you can easily find the number of electrons in them. Okay. For plus charge, you have to decrease the number of electrons. Okay. 1 plus charge means 1 less electron. Similarly, 1 minus charge means 1 more electron. Okay, is added. So here out of the given options, we'll talk about the correct answer only. Option D is the correct answer because we know that the atomic number of calcium is 20. So the number of electron will be 20 and then there are 2 plus charges. That means 2 electrons will be less. Okay, so 20 minus 2, that means 18 electrons. Similarly for argon, the number of electrons will be 18 because the atomic number is 18. Okay, and there is no plus and minus charge. For potassium, K plus, what is the atomic number of potassium? It is 19 and there is plus 1 charge, that means 1 less electron, so 19 minus 1, that is 18. Then for chlorine, the atomic number is 17, so the number of electron will be 17 and there is 1 minus charge, means 1 more electron is added, so plus 1, that is 18. So in this, all the species are having same number of electrons, 18. Therefore, this is the correct answer. Similarly, you can find out the number of electrons for other options as well. Question number 67 is from the chapter Structure of an Atom. two statements are given here. Let's read the statement 1. It says that the value of wave function psi depends upon the coordinates of the electron in the atom. So yes, this is a correct statement. There are different coordinates and each coordinate has different value of wave function psi. Therefore, the value of psi depends upon the coordinates of the electron in the atom. This is a correct statement. Let's come to the second statement. It says that the probability of finding an electron at a point within an atom is proportional to the orbital wave function. Orbital wave function is nothing but psi. Okay. So according to this statement, the probability of finding an electron is proportional to psi, which is not correct because the probability of finding an electron is proportional to psi square, not psi. Okay. So the second statement is incorrect. So statement 1 is true, but statement 2 is false. Option A will be the correct answer. Question number 68 is from states of matter and the question is the correct van der Waals equation for 1 mole of a real gas is. Okay. So we know that van der Waals equation, according to this equation, we write P plus n square A upon V square into V minus n into B equals to nRT, where n represents the number of moles, right? So in this question, 1 mole of a real gas is mentioned. That means the value of n will be 1. So if we put the value of n as 1 here in this equation, it becomes P plus A by V square. This side it becomes V minus B equals to n is 1, so only RT. Okay. So which option will be the correct one? According to this, the first option will be the correct answer. Question number 69 is again from states of matter and the question is the correct option in which density of argon is highest. Atomic mass of argon is given. Okay. So we know that the density is equal to Pm by RT, right? R is a gas constant, so it will remain constant. M will be constant for argon. That means density will depend on pressure and temperature. Okay, P and T. So for maximum density, we have to find the one option in which the density is highest. So for maximum density, pressure should be maximum because it is directly proportional to pressure, and temperature should be minimum because density is inversely proportional to the temperature. So here in the second option we have 0 degree Celsius, that is a less temperature, but pressure is also less here. Pressure should be maximum. So in which case we are having maximum pressure? In the third and fourth option, pressure is maximum 4 atmosphere, but temperature is minimum in case of third only. Okay, so third one is the one option in which the temperature is minimum but the pressure is maximum. So option C will be the correct answer. Question number 70 is from the chapter P block elements and the question is which of the following is correctly matched? Basic oxides. So here we have indium oxide In2O3, then potassium oxide K2O and then SnO2. So here out of the three, the third one is not a basic oxide. It is an amphoteric oxide. Okay. Other two are basic oxides. In the second one, we have to identify the neutral oxides. We have to see if it is correctly matched. Okay. So neutral oxides, here CO, that means carbon monoxide, and N2O. These two are neutral oxides, but NO2, the second one, is an acidic oxide. It is not neutral. Okay. In the third option, we have Mn2O7, then SO2, then TeO3. All these are acidic oxides, so this is absolutely correct match. Then in the last one, amphoteric oxides are matched with BeO. So yes, BeO is the amphoteric oxide. Then Ga2O3, it is also amphoteric oxide, but germanium oxide, GeO, is an acidic oxide. Okay. Therefore, the correct answer will be option number C. Question number 71 is from the chapter solutions and the question is which of the following is a positively charged sol? Options are methylene blue sol, Congo red sol, silver sol, antimony sulfide sol. Okay. So we know that the sols which are of inorganic origin, such as silver, gold, arsenic. So these salts are negative, okay? These are negative. Whereas the salts which contain hydroxide, such as aluminium hydroxide, then FeOH 3, then methylene blue sol, these are positive salts, okay? Therefore, the correct answer will be option A, methylene blue sol. Question number 72 is from the chapter Organic Chemistry, Purification part. Okay. Here we have to match the mixtures or samples with the correct technique which are used for their purification. So the first one is glycerol from spent lead. Now, what is the technique used for the purification? So the technique is distillation under reduced pressure. Okay. So A will be matched with number 3. Then the second one is chloroform aniline. And the method for purification of chloroform plus aniline will be distillation. So the correct match for B will be number 4. Then third one is fractions of crude oil. So the correct match for this will be fractional distillation. Okay. So C will be matched with number 2. And then the last one, D, aniline plus water. The correct match for this will be steam distillation. The correct match for D is number 1. Okay. So according to this, the correct answer will be option number A. A will be matched with 3, B will be matched with 4, C will be matched with 2, and D will be matched with 1. Question number 73 is from the chapter Haloalkanes and Haloarenes, and the question is, which amongst the following reactions of alkyl halides produces isonitrile as a major product? So isonitrile means the alkyl group should be bonded with nitrogen. Okay, it should look like this, RNC. This is isonitrile. Isonitrile. Whereas if it is bonded with carbon, then it will be nitrile. Now here 4 reactions are given, out of which 3 reactions will give nitrile. The first one will give nitrile, then the third one will give nitrile, and the last one will also give nitrile. Whereas only second one, where alkyl halide is reacting with silver cyanide, will give isonitrile. Why? Let's see. For example, if we take the third reaction where alkyl halide is reacting with KCN, okay? So in this one, we have alkyl halide. Here, the alkyl group will have partial positive charge, whereas halide part will have partial negative charge, right? Because this is more electronegative. Now it will react with KCN, for example. So in this KCN, potassium will have positive charge, carbon will have negative charge along with lone pair of electron, right? Now here this carbon, because of the negative charge on it, will act as the nucleophile, okay? Carbon will act as nucleophile. Therefore, it will attack the alkyl group, okay? This carbon will attack the alkyl group and it will remove the halide part from here, okay? So it will result in the formation of RCN because carbon has attacked the alkyl group. So it will form RCN, that means nitrile. And it will happen with other reactions also, except that with silver cyanide, because silver cyanide bond is covalent bond, whereas potassium cyanide was ionic in nature, but silver cyanide is covalent bond. So silver will form a covalent bond with carbon. So let's see the reaction here. Here we have alkyl halide. We know that alkyl part will have partial positive charge, halide part will have partial negative charge. Now when it is reacting with silver cyanide, then silver and carbon will be bonded, okay, by a covalent bond, but nitrogen will have the lone pair of electron, okay? Here only nitrogen will have the lone pair of electron. So in this case, nitrogen will act as a nucleophile. Okay, carbon is not acting as the nucleophile. Nitrogen is acting with as nucleophile. So this nitrogen will attack the alkyl part in this case. Okay, so nitrogen will be bonded with alkyl. So RNC will be formed. which is isonitrile. Got it? Therefore, only in the second reaction, that means B only, isonitrile will be produced as the major product. Okay, so option C, B only will be the correct answer. Question number 74 is from P block elements. And here we have to match list 1 containing hydrides with list 2 containing the type of hydride. Okay. So before we discuss this, we should know that the elements which are from S block, okay, S block elements, they form which type of hydride? They form ionic or saline hydride. Then if we talk about the P block elements, they form covalent hydrides. Covalent. Even under P block, the group 13 elements form electron deficient hydrides. Okay, electron deficient. Then group 14 elements form electron precise hydride. Electron precise. Whereas group 15 elements form electron rich hydrides. Okay. And if we talk about the D block elements, they form metallic hydrides. Metallic hydrides. Okay. So here, if you look at the table, which one is the D block element? The last one. Okay. So here it will form metallic hydride. That means D will be matched with number 3. Then S block hydride is the first one, sodium hydride. So it will form ionic or saline hydride. Okay. So A will be matched with number 2. Then the second one, pH3. Phosphorus belongs to group 15, so it will form electron rich hydride. So B will be matched with number 4. Then C, germanium, is a group 14 element, so it will form an electron precise hydride. So C will be matched with number 1. Okay, so A will be matched with number 2. Then B will be matched with number 4. C will be matched with number 1 and D will be matched with number 3. Okay. So according to this, the correct answer will be option number D. Question number 75 is from the chapter Chemical Bonding and Molecular Structure. And the question is, which one of the following statements is incorrect related to molecular orbital theory? So let's read the statements. The first statement says that pi star antibonding molecular orbital has a node between the nuclei. Yes, this is a correct statement. Okay. Then we come to the second statement. It says in the formation of bonding molecular orbital, the two electron waves of the bonding atoms reinforce each other. Yes, this is also correct. The two electron waves in the formation of bonding molecular orbital reinforce each other due to constructive interference. Okay. Then let's come to the third statement. It says molecular orbitals obtained from 2px and 2py orbitals are symmetrical around the bond axis. So which is incorrect because these are unsymmetrical around the bond axis. Okay. Unsymmetrical, not symmetrical. So this is incorrect statement. Then the last statement says that a pi bonding molecular orbital has larger electron density above and below the internuclear axis. This is also correct statement. So the only incorrect one was the third one. So option C is the correct answer. Question number 76 is from the chapter Equilibrium, and the question is an acidic buffer is prepared by mixing option A, weak acid and its salt with strong base, option B, equal volumes of equimolar solutions of weak acid and weak base, option C, strong acid and its salt with strong base, and option D, strong acid and its salt with weak base. So we know that an acidic buffer is prepared by mixing a weak acid such as acetic acid CH3COOH and its salt with a strong base CH3COONA. Okay, so this will give you an acidic buffer. That means option A, weak acid and its salt with strong base, will be the correct answer. Question number 77 is again from organic chemistry, and the question is reagents which can be used to convert alcohols to carboxylic acids are. So we know that in order to convert alcohols to carboxylic acids, we need strong oxidizing agents, right? Strong oxidizing agents. Because if it is not strong enough, then alcohol will be converted into aldehyde, not carboxylic acid. So out of these, let's see which are strong oxidizing agents. First one, CrO3 and H2SO4. Yes, this is strong oxidizing agent. Then second one, K2Cr2O7 and H2SO4. These are also strong oxidizing agent. Third one, potassium permanganate is also strong oxidizing agent. Fourth and fifth are not strong oxidizing agent. They will take alcohol into aldehyde, not carboxylic acid. So A, B and C will be the correct answer. Okay. Option C, A, B, C only will be the answer. Question number 78 is from P block elements, and the question is select the element M whose trihalides cannot be hydrolyzed to produce an ion of the form MH2O6 3+. Okay. So 6 water molecules are to be bonded with the M, element M. So here out of the given options, the answer will be boron, because we know that for boron, the maximum covalency that is possible is 4. Okay. Maximum covalency is 4. So it cannot form bond with 6 molecules. So option D will be the correct answer. Question number 79 is from the chapter Chemical Kinetics, and the question is the correct options for the rate law that corresponds to overall first order reaction is. So to find out the order, we have to add up the pars, okay, which are written on the concentration. If on adding the par we get 1, it means it is a first order reaction. If we get 2, it means it is a second order reaction, and so on. So let's see, in the first one, the par on A is 0 and the par on B is 2. So on adding them, we'll get 2. So this is a second order reaction, not a first order reaction. Let's come to the second one. Here we get 1 on both. So 1 plus 1, 2 again. In the third one, we have half on A and 2 on B. So half plus 2 will not give 1. Okay. But we have to get 1. Then in the last option, we have minus half and 3 by 2. If we add minus half and 3 by 2, what do we get? We get 2 by 2, that means 1. So it means it is a first order reaction. First order reaction. So option D will be the correct answer. Question number 80 is from the chapter Amines, and the question is which amongst the following compounds or species is least basic? So we know that easier the donation of electrons, more will be the basic character. Okay. Easier the donation of electron, more will be the basic character. And if it is difficult, or we can say if there is difficulty in donation of electron, it will have less basic character. Okay. Less basic character. So now let's see, in the first option we have two NH2 groups. So both these nitrogens will have lone pair of electron which will be involved in resonance. Okay. So here these electrons are not available for donation. Okay. Electrons are not available for donation, so it will not be of basic character, or we can say its basic character will be very less. Then in the second option, again two NH2 groups will have lone pair of electrons which will be involved in resonance, but this time these electrons will be more actively involved in resonance because they have to stabilize a carbocation. Okay. So here it is very difficult to donate the electrons. Okay. Oxygen also has lone pair of electron, but nitrogen is a better donor than oxygen. Okay. In the third one, again two NH2 groups have nitrogen which will have lone pair of electrons and they will be involved in resonance, but there is a third nitrogen which has lone pair of electrons available for donation, so it will be more basic in nature, more basic because of the availability of lone pair of electron on this nitrogen. Okay. In the last one again, two NH2 groups will have lone pair of electrons which will be involved in resonance, and the third nitrogen does not have any lone pair of electron. So here we have to identify the least basic compound. That means the compound in which it is most difficult to donate the electron. So it will be the second one, because the electrons will be involved in the stabilization of the carbocation here. So it's very difficult to remove these electrons or use these electrons for donation. Okay. So option B will be least basic in nature. So option B is the correct answer. Question number 81 is from the chapter Coordination Compound, and the question is, which of the following forms a set of complex and double salt respectively? So in the first, second and last options, both the salts given are complex salts. Okay, both are complex salts. But in the third option, the first one is a complex salt and the second one is a double salt. Okay, this one is a double salt. And this double salt is also known as potash alum. Potash alum. So the correct answer will be option number C. Question number 82 is from the chapter Polymers. Here two statements are given. The first statement says that high density polythene is formed in the presence of catalyst triethyl aluminium and titanium tetrachloride. So yes, this is absolutely correct statement. The second statement says high density polymers are chemically inert. This is also correct statement. So both the statements are correct, okay, or both the statements are true. So option C will be the correct answer. Question number 83 is from the chapter Hydrocarbons, and the question is, which amongst the following compounds will show geometrical isomerism? Okay. So to check which one shows geometrical isomerism, we should see that if we have double bond, carbon-carbon double bond, then each of the carbon should have two different groups bonded to it. Okay, if we look at this carbon, so it should have different groups bonded to it. These two groups, group A and group B, should not be same. Okay, they should be different. Similarly, the second carbon of the double bond should also have two different groups. If it has the group C and D, then C and D should be different groups. Okay. Now let's check. In the first option, we have pent 1-ene. So if we draw the structure of pent 1-ene, we have 5 carbons. So 1, 2, 3, 4, 5. And we have double bond at the first position. Now, this first carbon will have two hydrogens attached to it, right, in pent 1-ene. So these two groups are same. These are not different. So it will not show geometrical isomerism. They should be different groups. Then in the second one, we have 2,3-dimethyl but 2-ene. So let's see the structure here. We have 4 carbons. So 1, 2, 3, 4. Okay. Then at the second position, we have double bond. Now we have to check these two carbons which are bonded by double bond. Now in these two carbons we have methyl groups attached to them. And also the first carbon of this compound is having 3 hydrogen. So if we talk about this carbon of the double bond, it has 2 methyl groups attached to it. Both the groups are same, okay? 2 methyl groups are attached. Therefore it will not show geometrical isomerism. We come to the third option. We have 2-methyl prop 1-ene. So let's see the structure. Here we have CH3, CH3, and then here we have double bond CH2. Okay, CH2. So if we write hydrogens separately, we can see that this carbon of the double bond is having two similar groups. Okay, two hydrogens. So this will not show geometrical isomerism. Okay, then we come to the last option. 3,4-dimethyl hex 3-ene. So 6 carbons, let's draw them. 1, 2, 3, 4, 5, 6 carbons. Okay. Now we have double bond at third and fourth position, right? So between third and fourth carbon, we have a double bond. So we have to check these two carbons. Okay. Now let's see. Here we have methyl group. Third and fourth carbon will have methyl groups attached to them. Now this side, we can see that this carbon is having ethyl group, this side, and this side methyl group. So these are two different groups. Similarly, if we check this carbon of the double bond, this side we have ethyl group and this side we have methyl group. So these carbons are having two different groups. Therefore, it will show geometrical isomerism. So option D will be the correct answer. Question number 84 is from inorganic chemistry. Here two statements are given. Let's read the first statement. It says that hydrated chlorides and bromides of calcium, strontium and barium on heating undergo hydrolysis. So this is not correct because the hydrated chlorides and bromides of these elements on heating undergo dehydration. Okay, they undergo dehydration, not hydrolysis. Let's come to the second statement. It says hydrated chlorides and bromides of beryllium and magnesium on heating undergoes dehydration. So this is also incorrect because the hydrated chlorides and bromides of these elements on heating undergo hydrolysis. So the statements are just reversed. Okay. So according to this, both the statements are false. That means option D will be the correct answer. Question number 85 is from the chapter Haloalkanes and Haloarenes, and the question is the correct order for the rate of alpha beta dehydrohalogenation for the following compounds is. So what happens in this reaction? One hydrogen and one halogen are removed from adjacent atoms. Okay, that means from alpha and beta positions. So there is a double bond introduced between alpha and beta position. Okay. So let's see. In the first compound, we already have a double bond here. Okay. Now here we have a halogen, iodine. Okay. What is the alpha position? The first position is the alpha position and the second position is the beta position. Okay. So a double bond will be introduced between these positions, alpha and beta position. So let's see what type of compound will be formed. This double bond was already there and another double bond will be introduced between alpha and beta position. That means at this position. Okay. So this is the first compound that will be obtained. Then in the second one, this is the iodine, halogen. This is the alpha position and this is the beta position. So a double bond will be introduced between these positions. So let's see what will be formed. It will look like this. The compound will look like this. Okay. Then in the third one, we have this halogen. So the alpha position is this one. This one is the alpha position and the beta position is this one. Okay. So let's see what will be the type of compound that will be formed. This will be the compound that will be formed. Okay. Now more the stability of the alkene, more will be the rate of the reaction. So which alkene seems to be most stable? The first one, right? Because of resonance. So this is the most stable compound. So it will have the maximum rate of reaction. Maximum rate. Then out of second and third, which one seems to be more stable? The third one. Okay. So this is less stable than the first one. Less stable than the first one. And the second one is least stable. Least stable. So it will have minimum rate of reaction. Minimum rate of reaction. So here we have to arrange which one is minimum, second number. Then after that, third one, and the maximum rate is for the first one. Okay. So this will be the correct order for the rate of alpha beta dehydrohalogenation reaction. So according to this, the correct option is option number D. Question number 86 is from the solid states and the question is how many number of tetrahedral voids are formed in 5 mole of a compound having cubic close packed structure. So cubic close packed structure means CCP structure and it is similar to FCC structure. Okay. Now what happens in FCC? The number of atoms Z is 4 and the number of tetrahedral voids is 8. So when the number of atom is 4, then the number of tetrahedral voids is 8. So when there are 4 moles of atom, that means the number of moles is 4, then how many tetrahedral voids will be there? 8 moles. Okay, number of tetrahedral voids will be 8 moles. Now here it is given that there are 5 moles of a compound. So for 5 moles, what will be the number of tetrahedral voids? 8 by 4 into 5. moles. Okay. So if we solve this, we get 10 moles. And we know that 1 mole is equal to 6 into 10 to the power 23. So 10 moles will be equal to 6 into 10 to the power 24. So this is the number of tetrahedral voids that will be present in 5 moles of that compound. So option D, 6.022 into 10 to the power 24 will be the correct answer. Question number 87 is from the chapter Coordination Compound. And here the question is type of isomerism exhibited by the compounds and the value of coordination number of central metal ion in all these compounds respectively is. Okay. So let's see the coordination number first. In the first compound we can see 6 water molecules are bonded with chromium. That means the coordination number is 6. Okay. In the second one we have 5 water molecules and 1 chlorine. So 5 plus 1 6 again. Then in the third one, 4 water molecules and 2 chlorine. So 4 plus 2 again 6. That means it is clear that the coordination number is 6, which is given only in the last option. Okay. Also, we know that these are types of hydrate isomers. Hydrate isomers are also known as solvate isomers. So option D will be the correct answer. Next question says that the correct sequence given below containing neutral, acidic, basic and amphoteric oxide each respectively is. Okay. So here the correct answer will be option number D. Okay. NO is a neutral oxide. Then carbon dioxide is an acidic oxide. We know that. Calcium oxide is basic oxide. Okay. Whereas zinc oxide is an amphoteric oxide. Okay, so option D will be the correct answer. Question number 89 is from the chapter General Principles and Processes of Isolation of Elements, and the question is read the following statements and choose the set of correct statements. So the first statement says that chrome steel is used for cutting tools and crushing machines. Yes, this is a correct statement. Then the second statement says that the fine dust of aluminium is used in paints and lacquers. This is also correct. Then the third statement says copper is used for reduction of alcohol. No, this is illogical statement. The fourth statement says that zinc dust is used as a reducing agent in the manufacture of paints. This is also correct. Then the last statement says that iron is used for galvanizing zinc. This is incorrect. In fact, it's just the opposite. That means zinc is used for galvanizing iron. Okay. So the correct statements are A, B and D. That means option C will be the correct answer. Question number 90 is from the chapter Haloalkanes and Haloarenes, and the question is choose the correct sequence of reagents in the conversion of 4-nitrotoluene to 2-bromotoluene. Okay, so we have 4-nitrotoluene, that means this compound CH3 here and nitro group at this position, and it has to be converted into 2-bromotoluene, that means CH3 here and bromine group at the ortho position. Okay, so this conversion has to take place. We have to choose the correct sequence of reagents that will be used in this conversion. Okay, so first bromine should be added at the ortho position. Okay, then this NO2 group should be reduced. So let's see. First we have this reactant, that means 4-nitrotoluene. Okay, CH3 NO2 here. Now the reaction starts. So first step will be the addition of bromine. So the product that we will get here is CH3 here and bromine group will be added here and this NO2 group will remain here. Okay. Now this NO2 group has to be reduced into NH2 group. Okay. So for that we have to do reduction with Sn plus HCl. Okay, this will be the reduction of nitro group into NH2 group. So the product that we will obtain here is CH3 here, bromine at the second position, and here we have NH2 now. Okay, now this NH2 will be further converted into N2 plus Cl minus with the help of NaNO2, NaNO2 and HCl. So what do we get here now? CH3 here, bromine here, and at this position we have N2 plus Cl minus. Okay, and now we have the last step, that means reduction of this N2 plus Cl minus into hydrogen. Okay, so H3PO2 should be used and we'll get the final product here. CH3, bromine at the ortho position, and this N2 plus Cl minus will be converted into hydrogen. So we can simply leave it or we can write hydrogen. It will be the 2-bromo-toluene. 2-bromo-toluene. So what are the sequence of reagents? First bromine, then Sn plus HCl. In the third option we have the sequence bromine, then Sn plus HCl, then NaNO2 plus HCl, this one, and then we have H2O or H3PO2. So option C will be the correct answer. Question number 91 is from the solid states, and the question is, how are edge length A of a unit cell and radius R of the sphere related to each other in CCP structure? Okay, so we know that root 2A is equal to 4R, right? So A will be equal to 4 by root 2R. That means 2 root 2R. Okay, so A will be equal to 2 root 2R. Option D will be the correct answer. Now in this question we have to identify the product in the following reaction. Okay, so we have this compound initially. First it reacts with KCN, right? KCN. So it will give, see, this chlorine will be replaced by CN. So what do we get here? Here we'll get CN. Then it reacts with H2O or HCl. Okay, it is heated. So this CN will be replaced by carboxylic group, C double bond O OH. Okay, COOH. Now in the next step it reacts with bromine or red phosphorus, and hydrolysis is done. Okay, this is the first step, this is the second step. So what will happen? Bromine group will be introduced here. This is the compound. Here we have COOH and here we have bromine also introduced at this point. So according to this, the correct option will be option number B. Okay. Question number 93 is from organic chemistry. Here two statements are given. Let's read the statement 1. In an organic compound, when inductive and electromeric effects operate in opposite directions, the inductive effect predominates. So this is incorrect statement, because if these two effects operate in opposite direction, then the electromeric effect will predominate. Okay, so this statement is false. Then let's come to the second statement. It says hyperconjugation is observed in orthoxylene. Yes, it is correct. Okay, in orthoxylene, hyperconjugation will be observed. And what is the structure of orthoxylene? This is the benzene ring. Here we have CH3 and another CH3 at ortho position. Okay, here hyperconjugation will be observed. So the first statement is false, but the second one is true. Okay, statement 1 is false, but statement 2 is true. Option B will be the correct answer. Question number 94 is from the chapter redox reaction, and the question is, the correct option for a redox couple is option A, both are oxidized forms involving same element. Option B, both are reduced forms involving same element. Option C, both the reduced and oxidized form involve same element. And last option is cathode and anode together. So it is very simple. We know that the redox couple involves one oxidized form and the other reduced form of the same element. Okay, so option C will be the correct answer. Question number 95 is from the chapter D and F block elements. Here two statements are given. One is assertion and the other is reason. So let's read the assertion. It says that ionization enthalpies of early actinoids are lower than for early lanthanoids. That means for early actinoids, the ionization enthalpies are low, whereas for early lanthanoids, the ionization enthalpies are high. Okay. So yes, this is a correct statement. Now let's read the reason. It says that electrons are entering 5f orbitals in actinoids which experience greater shielding from nuclear charge. So yes, since in early actinoids the 5f orbitals are entering, okay, so it shields them from the nuclear charge. That means they are less tightly bound. Okay, actinoids are, the electrons in the actinoids are less tightly bound, therefore they can easily be removed. They can easily be removed. Therefore they have low ionization enthalpies as compared to that of lanthanoids. Okay, so both A and R are true, and R is the correct explanation of A. Option C will be the correct answer. Question number 96 is from thermodynamics, and the question is, consider the following reaction. So here we have the reaction. What is the enthalpy change for the decomposition of 1 mole of water? So this is very simple, but you have to pay attention that in this reaction, water is being formed by the combination of hydrogen and oxygen, right? But we have to find the enthalpy change for the decomposition of water. That means the opposite reaction. Okay, so the opposite reaction will be 2H2O. It will give hydrogen and water, oxygen. Okay, so this will be the reverse of the reaction that is mentioned in the question. Okay, and the enthalpy will also be reversed. So in this reaction it is minus 483.64 kilojoule. So for the decomposition of water it will become plus 483.64 kilojoule. But this is for 2 moles of water. If you look at this reaction, okay, 2 moles of water are there. So for 1 mole of water, 1 mole of water, it will be just the half. That means 483.64 by 2 kilojoule. Okay, and on solving this, what do we get? We get 241.82 kilojoule. So option B will be the correct answer. Question number 97 is from the chapter Environmental Chemistry, and the question is, which statement is not true about photochemical smog? So we have to find the incorrect statement. The first statement says that photochemical smog is harmful to humans but has no effect on plants. This is incorrect because it is harmful to humans as well as plants. Okay. Now the second statement says plants like Pinus juniperus can help in reducing the photochemical smog. This is correct statement because these plants can metabolize nitrogen oxide. They can metabolize nitrogen oxide. Therefore, their plantation can help to reduce the photochemical smog. Then the third statement says photochemical smog occurs in warm, dry and sunny climate. This is also correct. The last statement says common components of photochemical smog are ozone, nitric oxide, acrolein, formaldehyde and peroxyacetyl nitrate. So this is also a correct statement. The only incorrect statement was the first one. So option A will be the answer here. Question number 98 is from the chapter Solutions, and the question is, which amongst the following aqueous solution of electrolytes will have minimum elevation in boiling point? Choose the correct option. Okay. So we know that the elevation in boiling point delta TB is given as I, that means iota, into Kb, that is a constant, into M, that is molarity. Okay. So these are constants. So delta TB, that means elevation in boiling point, will be proportional to the molarity. Okay. We have to find the option in which it has the minimum elevation in boiling point. So for minimum elevation in boiling point, the molarity should also be minimum. Okay. In the first option, we have 0.05 molar NaCl. In the second one, we have 0.1 molar KCl. In the third one, we have 0.1 molar MgSO4. And in the last one, we have 1 molar NaCl. So, in which case we have minimum molarity? In the first one, 0.05. This is the minimum. So, the elevation in boiling point will also be minimum. Option A will be the correct answer. Question number 99 is from alcohols, phenols and ethers. Here we have to identify the compound X in the given reaction. Okay. So the reactant is bromine. Then here we have the benzene ring. And here we have chlorine. Okay. Now it reacts with magnesium in dry ether. So what will be obtained? Grignard reagent will be obtained as the intermediate. Okay. So the benzene ring here. Here we have the chlorine, and this side magnesium will be introduced. So MgBr. That means Grignard reagent, and this is the intermediate in this reaction. Now it further reacts with D2O. So the final product that we will get is that D will be introduced opposite to chlorine. Okay. So this is the benzene ring. Here we have chlorine, and opposite to it this MgBr will be replaced by D. So this is the final product. That means option A will be the correct answer. And now this is the last question, and the question says that the major product formed in the following conversion is. Okay. So let's see the structure of the reactant. Here we have this pentagon, then we have double bond O, then CH2, C double bond O, and then CH3. Now it reacts with NaBH4. So what will be formed? Pi bond will be broken, and in place of carbon oxygen double bond we'll have carbon and OH bond. Okay. So let's see. This is the pentagon. Here in place of double bond O we will have OH. Again here CH2, then COH, and then CH3. Then it is heated with sulfuric acid, H2SO4. So what will happen? Dehydration will take place, and then double bonds will be introduced. So this is the pentagon. Here we have a double bond, okay, between the alpha and beta position with respect to OH group. Okay. Now here CH, then double bond CH, and then CH3. So this is the final product. The structure will look like that of the first option. Okay. So option A will be the correct answer. So here we complete all the questions from NEET 2023 Manipur paper. We'll be back with another session very soon. Till then, keep learning, keep scoring high. For a better understanding, I would suggest you to practice same questions from our website www.examsnet.com. And for more information, please download our app from the link given in the description box. Thank you so much.